Good day everyone, we are the group who will present the nature of geometry. And I'm Angeline R. Magtubo, the first reporter of our group, and now I am going to discuss the introduction about geometry and about the transformation. So first, let us know the meaning or the definition of geometry. So, the geometry is derived from the Greek words geo, meaning earth, and metrein, meaning measure. So, it is also a branch of mathematics that deals with the measurement, properties, and relationship of points, lines, angles, surfaces, and solids. It also deals with shapes, angles, dimensions, and sizes of a variety of things we see in everyday life. We use in various daily life application, such as when we do arts, when we sculptures, also in nature we use geometry in sports or in machines or different kind of cars and much more. Let's proceed naman sa definition of transformation. When we say transformation, it describes sizes, positions, and orientation of shapes such as flips, turns, slides, and scaling. So, always remember the simplest meaning of transformation is something to change, especially when it comes in shape. So, in geometry, it is a specific way to describe how a figure is changed. So, there are the main transformations, so it includes four, which is reflection, translation, rotation, and dilation or enlargement. So, let's proceed sa renaming transformation. So, it is a common practice to name a shape using capital letters of the English alphabet. So, when we are performing transformation, the initial object or the original is called pre-image, while the final object or the after transformation is called image. Here's sa example natin, yung pre-image natin or the original object natin is labeled with capital letters which is A, B, C, and D. While sa image naman natin or the after transformation or the final object, as you can see, the transform shape is labeled with the same letters which is A, B, C, and D, but here may kasama ng prime symbol. Kapag sinabi nating prime symbol, ito yung ginagamit like sa example natin to represent feet. As you can see, like siya ng apostrophe. Proceed naman tayo sa four main transformation. So, first yung translation or slide of an object. So, translation is the shape moves in one position to another in any direction. So, as you can see sa image, same size, same object, but different position. Here's a translation, pwedeng vertical or horizontal slide ng shape. So, any transformation that does not change the size of the object is called rigid transformation. It includes translation, rotation, and reflection. While any transformation naman na changes the size of the object is called non-rigid transformation. So, the example of this is the dilation or enlargement. Second naman is reflection or a flip object. When we say reflection, it is a shape gives a mirror image. As you can see rin sa image, same size, same shape, but opposite orientation. When we say reflection kasi, the best example nito is kapag humaharap tayo sa isang salamin. Same size pa rin and hindi rin nag-iiba yung shape natin. So, when it comes to object or shape, if you folded the two shapes together, same shape pa rin yung lalabas. The third is rotation. So, when we see rotation or turn, it moves a shape around a point. So, this is the transformation that turns the figures about a fixed point. As you can see rin sa image, same size, same object, and orientation. But here is naka-rotate or naka-turn yung object. So, yung rotation ng figure pwedeng clockwise or counterclockwise. So the last main transformation is dilation or enlargement. So the dilation, it is the change the size of a geometric figure but does not change its shape. So, ang lagi nating tatandaan here sa dilation, as you can see naman sa image, the use of dilation is to create an image larger than the original. So, meaning, same shape pa rin, same orientation, but different size. Meaning, ang nagbabago lang dito sa dilation is size, pero same shape pa rin na ginamit, or same figure pa rin. Here sa example natin, yung image A natin is maliit lang. Pero pag tinransform natin into dilation, yung image A natin is nagiging malaki yung shape niya or yung size niya. But isang shape pa rin siya and hindi siya nag-iiba.
Hi, my name is Janami Dita Kanay and I will be discussing about translation. A translation in math moves a shape left or right and or up or down. Translated shapes look exactly the same size as the original shape and hence the shapes are congruent to each other. They just have been shifted in one or more directions. This is just movement of the shape from one place to another. There is no change in the shape. The direction or the path of this change in position of the subject vary. Initially, the object can move left and turn right and so on, while translating all the points on the shape will shift by the same number of units. For better understanding, here is some graphs and visual for help. Translation in geometry. In the figure, the preimage is ABC and its image is ABC. Here, the ABC is translated in the following two ways, one after the other, to form ABC. Move up vertically by 3 units and then move right horizontally by 2 units. The image is like the object. We just have to make it congruent to each other. Here's what to be reminded of. While translating the triangle to the left, right, up, down, we move all the points of the triangle by an equal number of units in the same direction. As what I've said, they need to be congruent. Our next topic is preimages and images of translation. As we have just seen, a shape before translation are applied is known as preimage, and the shape that is obtained after the application translation is known as image. In simple words, preimage is the shape before translation. Image is the shape after translation. Look at the following figure where ABCD is the preimage and the ABCD is the image of the ABC. Image is the outcome of what we have translated, while pre-image is the original shape of what it looks like. The translation rules. When the shape is moved toward the left by k units, then replace x with x minus k. When the shape is moved toward the right by k units, then replace x with x plus k. When the shape is moved up by k units, then replace y with y plus k. When the shape is moved down by k units, then replace y with y and minus k. Example, what are the new coordinates when the transition x, y to x minus 2, y plus 3 is applied to the point 2 and 5? Solution. The coordinates of old point preimage or xy is equivalent to 2 and 5. Now applying the given transformation to this point. Y minus 2 is equal to 2 minus 2 equals to 0. Y plus 3 equals to 5 plus 3 equals to 8. Thus, the coordinate of the translated point image are 0 and 8. To translate the preimage to image, you have to replace of some point of the preimage to convert it into an image. Moving on to graphing translations. To graph the translation of a shape, we follow the steps below. Identify the verticals of the shape, apply the given transformation on each of the verticals to find the new vertical, then just plot the new points on the coordinate plane and join them as per the given shape. Example, a shape is formed with verticals 1, 8, -3, -5, -4, 7, and -6, -2. Plot the image of this shape with respect to the translation x, y to x plus 6, y plus 1. Our next step is computing the new coordinates of each of the given verticals. Since x is equivalent to plus 6 and the y is equivalent to plus 1, we have to use it to get our new coordinates. The table shows the new coordinates of each of the given vertices. It also shows how to compute and the output of the new coordinates. To plot it to the graph, you have to follow the new coordinates after the translation to get what the graph will look like. If your pre-image and image is different, there is something wrong with your computation for the new coordinates and the old coordinates. Reflection in mathematics is a type of rigid geometrical transformation that maintains the object's size and shape. Unlike other transformations such as dilation, which changes the size of shape, reflection results in congruent images. Reflection in math definition is the mirror image of a figure over a line, drawn or imaginary, known as the line of reflection, or over a point known as the reflection point. Sometimes the reflection is known as a flip. In short, basically the reflection in mathematical looks like two congruent repetition of an object, same size, same shape, over a line or a point. The difference between translation and reflection is that translation is when we slide a figure into any direction, while reflection is when we flip a figure over a line. Reflection in a line. The line of reflections allowed for a distinction of congruent images, the pre-image and the image. The line of the reflection is a perpendicular bisector in response to the congruent images. Hence, it divides the plane into two congruent or equal parts. Figure 2 is an illustration of a reflection math example in coordinate plane. It shows the following. Change ABC, the pre-image, meaning the original image before the transformation. Change ABC is the image, but add a dash, meaning the mirror reflection after transformation. The y-axis, the line of reflection as it divides the plane into two congruent or equal parts. Mathematically, it can be stated that ABC is the reflection of ABC over the y-axis. It needs to be noted that the line of reflection will always be a perpendicular bisector the pre-image and image no matter their location on a plane. The line of reflection allows for the correct identification of the image and how it will be labeled in response to the pre-image when using coordinates x and y. Reflection in x-axis. In this section, the line of reflection is the x-axis. This means that the x-axis is the perpendicular bisector of the pre-image and the images. We have here figure 3. When the line of reflection is the x-axis, the x and y transform into x negative y, hence keeping x the same but flipping the y to a negative. The illustration shows the following. ABC with coordinates 7, 4, 4, 3, and 6, 2. In the pre-image, flip to ABC the coordinates 7, negative 4, 4, negative 3, and 6, negative 2 in the image. The difference between reflection in the line and reflection in x-axis is that reflection in the line both have positive numbers, while the x-axis has one negative number, which is meaning to say in line there is x and y, while in x-axis there is x and negative y.
Good day everyone, my name is Jessica Mativulang taking for BSA 1C. A rotation is a transformation in a plane that turns every point of a figure through a specified angle and direction about a fixed point. The fixed point is called the center of rotation. The amount of rotation is called the angle of rotation and it's measured in degrees. In determining the angle of rotation, the initial side is always along the positive x-axis and terminal side of the angle. Determine where the rotation stops. One of the most important and standard position is the arrow because it indicates how much the rotation has occurred. It is also important to note that if we change the arrow, it does change the measure of angle. And finding the center of rotation, we need to draw the bisector between the object and image. When you connect two corresponding points to each shape and just repeats the steps with two other points, the point where the bisector meets is the center of rotation. Magandang umaga sa inyong lahat. Ako si Jessica Mativulang from BSA 1C. Ang deletion na pagmamalaki ay isang proseso ng pagbabago ng sukat ng isang bagay o hugis sa pamamagitan ng pagbawas o pagtaas ng kanyang mga dimension sa pamamagitan ng ilang mga scale factor. Halimbawa, isang bilog na may radius na 10 unit ay maaaring babawasan ang sukat upang maging isang bilog na may radius na 5 unit. Ang ganitong paraan ay karaniwang ginagamit sa larangan ng photography, arts and crafts, paglikha ng mga logo at iba pa. Sa geometrya, may 4 na pangunahing uri ng transformasyon: pagsasalaysay, translasyon, refleksyon, at resizing o deletion. Ang deletion ay isang uri ng transformasyon na ginagamit upang palakihin o pakiliin ang isang bagay. Ang resulta ng deletion ay isang imahe ng katulad ng orihinal na hugis, ngunit may pagkakaiba sa laki. Ang deletion ay nilarawan ng tinatawag na scale factor. Kung ang deletion ay lumilikha ng mas malaking imahe, tinatawag itong enlargement. Kung ang deletion ay lumilikha ng mas maliit na imahe, tinatawag itong reduction. May mga tagian ng deletion. Ang bawat anggulo ay hugis na nananatili. Ang mga gitna na mga gilid hugis ay nananatili. Ang mga linya na parallel at perpendicular sa hugis ay nananatili. Ang mga imahe ay nananatili. May 2 uri ng deletion, horizontal at vertical. Sa horizontal deletion, ang function na y equals fx ay dinadala horizontally gamit ang isang scale factor. Habang sa vertical deletion, ito ay dinadala vertically gamit ang scale factor. Halimbawa ng deletion. Unang halimbawa, deletion scale factor. Kung ang orihin ang center ng deletion at may triangle na ABC sa coordinate plane, kung ang scale factor ay dalawa, ang bawat coordinate point ng original na triangle ay multiply ng scale factor. Ang deleted triangle ABC at ang mga coordinate points nito ay A, 0, 4, B, 4, 2, C, 4, 4. Formula X, Y, 2X, 2Y. Deletion scale factor. Kung ang orihin ng center ng deletion at may quadrilateral na ABCD sa coordinate plane, kung ang scale factor ay 1/2, ang bawat coordinate point na original na quadrilateral ay nagmumultiply ng scale factor 1/2. Ang deleted quadrilateral ay ABCD at ang mga coordinate points nito ay A, 1, 2, B, 2, 2, C, 1, 1, D, 1, 2, 1. Formula X, Y, 1/2, X, Y, 1/2.
So, we will define what is perimeter. Perimeter of a shape is defined as the total distance around the shape. Basically, perimeter is the length of any shape if it is expanded in a linear form. For example, if you walk around the edge of a playground, you are measuring its perimeter. So, right now, we will figure out how we can compute the perimeter of a rectangle. Rectangle is a figure shape with opposite side equal. Formula would be perimeter of a rectangle is equal to the sum of length of all sides. Example number 1. Find the perimeter of a rectangle with sides 10 inches and 4 inches. Solution would be perimeter is equal to 2 times length plus 2 times width. We just simply multiply the length times 2 and also the width times 2. So is equal to 20 plus 8 is equal to 28 inches. So the perimeter of a rectangle given in an example number 1 is equal to 28 inches. So next slide is about perimeter of a triangle. The triangle has 3 sides, therefore the perimeter of any given triangle, whether it is scalene, isosceles, or equilateral, will be equal to the sum of the length of all 3 sides. So, perimeter is equal sum of length of all sides. We just simply add all sides and makikita na natin yung perimeter ng triangle. So, sa example number 1, find the perimeter of triangle having the following dimension. A is 6 inches, B is equal to 8 inches, and C is equal to 10 inches. So, the solution would be perimeter is equal to A plus B plus C. So, according to the figure, or according to the example, the other side is 6 inches, 8 inches, and the 10 inches. So, the total is 24 inches. So, the perimeter is just simple as that. We will add the all side to figure out what is the perimeter of any shape. So, next topic is all about of a square is the measure of the space or surface occupied by it. It is equal to the product of the length of its two sides. So how can we calculate the area of a rectangle and the area of the square according to this example? So find the area of a rectangle with sides 4 cm by 9 cm. 9 cm is the base and 4 cm is the height. So simply A is equal to B times height is equal to 9 times 4 is equal to 36 cm. So that would be the answer. And the square is 5 times 5 is equal to 25 inches. So next, the area of a triangle. The area of a triangle is defined as the total region that is enclosed by the three sides of any particular triangle. Basically, it is equal to half of the base times height. So the formula would be A is equal to 1 over 2 times base times height. Example, what is the area of a triangle with the base is equal to 3 cm and the height is equal to 4 cm? We will just simply multiply it. So 1 over 2 times 4 cm times 3 cm is equal to, the answer is 6 cm. The area of a parallelogram can be calculated by multiplying its base by the altitude or height. Example, the area of a parallelogram is 120 meters squared and its perimeter is 60 meters. What is the length of its side if its height is 8 meters? So the formula would be area is equal to base times height. Dahil given na ang area of a parallelogram in the example which is 120 meters squared, ang hinahanap natin dito sa example is base. So we will substitute the 120 meters squared sa area is equal to B times 8 meter. So we just simply divide it 120 meters squared over 8 meter. So the base would be 15 meter. The area of the trapezium basically depends upon the length of a parallel side and height of the trapezium. So according to the figure, there is base 1, base 2, height, and the area inside the shape. So find the area of a trapezium whose length of parallel side are 4 cm and 60 cm respectively, and the height is 3 cm. So the formula would be A is equal to 1 over 2 open parenthesis base 1 plus base 2 close parenthesis times height. Solution, given base 1 is equal to 4 cm, base 2 is equal to 6 cm, height is equal to 3 cm. So A is equal to 1 over 2 open parenthesis base 1 plus base 2 close parenthesis height is equal to 1 over 2 4 plus 6 times 3. So the answer is 15 square centimeter. Circumference of the circle or perimeter of the circle is the measurement of the boundary of the circle. The circumference or perimeter of circle is equal to 2 pi r. Another way to calculate the circumference of a circle is by using the formula circumference is equal to pi times diameter. Example, if the radius of the circle is 25 units, find the circumference of the circle. So the pi would be equivalent to 3.14. So the formula would be circumference of a circle is equal to 2 pi radius. So C is equal to 2 times pi times 25. C is equal to 2 times 3.14 times 25. So the answer would be 157 units. Our topic is all about volume and surface area. Volume and surface area are calculated for any three-dimensional geometrical shape. The surface area of any given object is the area or region occupied by the surface of the object, whereas volume is the amount of space available in an object. Rectangular box. The volume of the rectangular box is known by multiplying the length, the width, and the height. That is, B is equal to length times width times height. The surface area of a three-dimensional figure is the sum of the areas of all surfaces of the composed figure. Hence, for a rectangular box with a square base, the surface area is twice the area of a square, plus 4 times the area of a rectangle. So, it's A is equal to 2 area square plus 4 area of a rectangle. Or A is equal to 2 open parenthesis length times height plus width times height plus length times width close parenthesis. Example, find the volume and the surface area of a rectangular box. So according to the figure, the rectangular box have 4 cm height, 6 cm width, and 8 cm length. So first we will like to figure out what is the volume. So volume is equal to length times width times height cubic. So B is equal to 8 times 6 times 4 cm cube. So the answer would be 192 cm cube. So next, how about the area? So the area formula is equal, A is equal to 2 open parenthesis length height plus width height plus length width. So we will substitute the given number. So A is equal to 2 open parenthesis 8 times 4 plus 6 times 4 plus 8 times 6 close parenthesis. So the total area is 208 centimeter. Cylinder is a simple geometric shape with two equal size and parallel circular base. The cylinder's volume of the base, radius, and height is equal to area of base times height of the cylinder. Since the base is the circle, it can be written as volume is equal to pi r2 times height. The formula for the surface area of the cylinder is equal to the total surface area of the base of the cylinder and surface area of its side. So the formula would be A is equal to 2 pi r squared plus 2 pi r h. So this is how can we calculate the volume of a cylinder. So given in an example, the height is equal to 20 cm and the radius is equal to 14 cm. We will substitute it in the formula. The formula would be volume is equal to pi times radius squared times height. So we will substitute it. Volume is equal to 3.14 times 14 times 14 times 20. So the answer would be 12,308.8 centimeter cube. Next is a sphere. A sphere in mathematics is a three-dimensional figure that is related to the two-dimensional figure, the circle. The circle is defined as a set of points equidistant from the given point called the center. The sphere is the set of all points equidistant from the center in three dimensions. So the surface area of a sphere, the formula would be A is equal to 4 times pi times radius squared. So the volume of a sphere, the formula would be volume is equal to 4 over 3 times pi times radius cube. So this is how can we calculate the surface area and the volume of a sphere if the radius is 9 cm. So first, the volume of a sphere is equal to 4 over 3 times pi times r cube. So we will substitute the 9, which is the radius. So volume of a sphere is equal to 4 over 3 times 3.14 times 9 cube. So the answer is 3,053.628 centimeter cube. So the surface area is equal to 4 times pi times r squared. So we will substitute the 9 centimeter radius. So the total, so we will multiply it 4 times 3.14 times 81. The answer would be 1,017.87 centimeter the height is 6 centimeter, and the width is 2 centimeter, and the length is 8 centimeter. So the volume of a prism is equal to base area times height, or length times width times height. So we will substitute the given number. The volume of prism is equal to 8 times 2 times 6. So the answer would be 96 centimeter cube. So how about the surface area of a prism? Surface area of a prism is equal to 2 times area of the base plus perimeter of the base times height. So we will substitute the given number. So equal 2 times 16 plus open parenthesis 2 times 2 close parenthesis plus 2 open parenthesis 8 times 6. So is equal to 32 plus 20 times 6. The total number would be 152 centimeter square. So this one is the example of triangular prism. So how can we calculate it? Find the volume and surface area. So the figure would be 12 meter, 16 meter, and 20 meter height. So area of end of prism is equal to 1 over 2 times 12 times 16. So the total is 96 meter squared. So the volume of prism is equal to base times height. So 96 times 20 is equal to 1920 meter cube. Pyramid. Pyramids and cones are solid shapes that exist in three-dimensional space. A pyramid has sides that are triangular face and a base. The base can be any shape. The total surface area of a regular pyramid is the sum of the area of its lateral faces and its base. The lateral surface area of a regular pyramid is L as A is equal to 12 times perimeter of a base times length height. So the formula for finding the volume of pyramid is P is equal to 1 over 3 times area of a base times height. Example, what is the volume of pyramid? First, figure out the shape of the base. So according to the figure, the width would be 6.3 centimeter, and the length is 11 centimeter, and the height is 15 centimeter. So we will figure out the area of the base first. So A is equal to length times width. So we will substitute the 11 cm and 6.3. So we will multiply it. So the total will be 69.3. So next, substitute the base area and the height into the formula for the volume. So volume is equal to 1 over 3 times base times height. So we will substitute the area of the base. This is the 69.3. So 1 over 3 is times 69.3 times 15. So the volume is equal to 346.5. So the volume of the pyramid is 346.5 centimeter cube. Cone. A cone is a solid with a circular base and sides that taper up toward the vertex. A cone is generated from rotating a right triangle around one leg. A cone has a slant height. So the formula of how can we calculate the volume of a cone is equal to 1 over 3 times area of the base times height, or 1 over 3 pi radius squared times height. Example, find the volume of an ice cream cone having a radius of 18 mm and a height of 80 mm. So the solution, as we know, radius is 18 mm, height is 80 mm. So the pi would be 3.14. So we will simply substitute it. Volume is equal to 1 over 3 pi times radius squared times height. So 1 over 3 times 3.14 times 18 squared times 80. The total is 27,143.36 mm cubed.
Hi, my name is Carmela S. Guzman and I'm going to discuss about the right triangle trigonometry. Trigonometry is the branch of mathematics that deals with the description of a triangle. The word trigonometry is derived from the Greek word trigonon, meaning triangle, and metron, which means measure. Plane geometry includes the study of figures like circles, triangles, rectangles, squares, parallelograms, and trapezoids. A triangle is a shape which you should be familiar with because it is one of the most important shapes in mathematics. A triangle is a geometric figure that has three sides and three interior angles. A triangle can be described completely by the lengths of its sides and the measures of its angles. Next is angle measurement. The angles of a triangle can be measured in terms of radians or degrees. The basic unit of measure is the degree. The size of an angle is based on how wide the angle is open. Angles are classified according to measures. The following shows the various types of angles and their descriptions. There are 5 types of angle: acute angle, right angle, obtuse angle, straight angle, and reflex angle. Acute angle is an angle that measures less than 90 degrees, while right angle is the angle that measures exactly 90 degrees. Obtuse angle is the angle that measures greater than 90 degrees but less than 180 degrees. Straight angle is the angle that measures exactly 180 degrees. Reflex angle is the angle that measures greater than 180 degrees. Now let's go with special triangles. There are two special triangles that are frequently used in trigonometry. These are the 30-60-90 triangle and the 45-45-90 triangles. The sides of each triangles have special relationships as shown in the following figures. Now, there are always rules of solving a triangle, rules or formula, but this is the rules of solving the 30-60-90 triangle. If you know the hypotenuse or the 90 degrees, then divide by 2 to get the short leg or the 30 degrees. If you know the short leg or the 30 degrees, then multiply by 2 to get the hypotenuse or the 90 degrees. If you know the short leg or the 30 degrees, then multiply by square root of 3 to get the long leg or the 60 degrees. If you know the long leg or the 60 degrees, then divide by square root of 3 to get the short leg or the 30 degrees. Next is the rules of solving the 45-45-90 triangle. If you know the short leg or the 45 degrees, then multiply by square root of 2 to get the hypotenuse or the 90 degrees. If you know the hypotenuse or the 90 degrees, then divide by square root of 2 to get the short leg or the 45 degrees. Trigonometric ratios. The six trigonometric ratios relate the sides of a right triangle to its angles. Specifically, they are the ratios of two sides of a right triangle and a related angle. Trigonometric functions are typically used to calculate unknown lengths or angles in the right triangle. The six functions are all related and can be defined in terms of one another. These trigonometric ratios are the sine, cosine, and tangent. The other three, the ratios cosecant, secant, and cotangent, are the reciprocals of the first three, respectively. The question is how to find the ratios in trigonometry. To get the sine, divide opposite by hypotenuse. To get the cosine, divide adjacent by hypotenuse. To get the tangent, divide opposite by adjacent. And to get the cosecant, divide hypotenuse by opposite. To get the secant, divide hypotenuse by adjacent. And to get the cotangent, divide adjacent by opposite.
Good day, everyone. I'm Jeremy Culopera, and I'm here to present the conic section and analytic geometry. Analytic geometry is the union of algebra and geometry. It is a branch of algebra that is used to model geometric objects, points, lines, and circles, which are the most basic. Conic section. A conic section is a curve obtained by the intersection of the surface of a cone with a plane. There are three types of conic section, which are the hyperbola, parabola, and the ellipse. The circle is a special case of the ellipse. Circle. So, circle by the definition is a set of all points in the xy plane that are fixed distance r from a fixed point H and K. Ang radius is equal to R and ang center will be H and K. So, ayan yung equation para sa circle na conic section. Circle in conic section. Magfo-form ang circle kapag mayroong conic section tulad ng nasa picture na dalawang cone na baliktaran at mayroong plane na nagka-cut through the conic section horizontally. Sa pangalawang picture, ito yung graph given the standard equation as x minus h squared plus y minus k squared is equal to r squared. Yung graph, yung representation ng circle which has the center h, k, at yung radius na r. So, sa third picture, which is XY plane, so ito yung circle given by radius of 4. So, merong 4 units away from the center at nakabuo ng circle by using radius of 4. So, sa example, graph the circle given x plus y squared plus y minus 3 squared is equal to 16. So, meron tayong given standard equation at kailangan natin i-graph. Sa first step is find the center and the radius. So, ang standard equation ng circle is x minus h squared plus y minus k squared is equal to r squared. So, yung center is negative 1 and 3 na nakuha sa h and k, while yung radius naman is 16 na nakuha sa r squared, and it will be radius positive or negative 4. Ang unang i-graph is yung center which is negative 1 and 3. So, negative 1 and positive 3 ang center. And to find the circle as construction in your xy plane, gagamitin yung radius na 4, which means 4 units away from the center going to the right, left, up, and down. So, merong 4 points na equidistant doon sa ating center. At yan ang makakatulong sa pag-graph ng ating circle given the equation x plus 1 squared plus y minus 3 squared is equal to 16. So, ayan yung graph sa conic section na circle sa example. Parabola is a set of all points x and y in a plane that are equidistant from a fixed line called directrix and a fixed point called focus. So here are the parts of parabola. We have here the vertex, isa sa pinakamahalagang part ng parabola. Second one is focus, point na nasa loob ng opening parabola. And directrix, na nagsisilbing wall ng opposite ng vertex at ng focus. So ayan yung parts ng parabola na gagamitin natin sa pag-analyze ng parabola sa conic section. So, ang general form or equation can be two forms. The first one is x minus h squared is equal to 4p y minus k. So, kapag ang open ng parabola is going up or going down, x minus h squared or yung exponent na 2 is nasa x. So, the second one is y minus k squared is equal to 4p x minus h. So, kapag naman ang parabola is going sideward, yung exponent na 2 is going with y. Let's have an example. So, ang pinapakita sa graph ay parabola sideway. Kapag ang parabola ay nag-open sideways, ang gagamitin na standard form is y minus k squared is equal to 4p x minus h. So, as I said earlier, kapag ang parabola is open sideward, yung exponent na 2 is nasa y. Sa pag-analyze ng parabola, all you have to do is kunin yung mga parts ng parabola, which are the vertex, focus, and directrix. So, how to write it in mathematically? Unahin natin ang vertex. Ang vertex natin is at the point of origin. So, pwede natin ilagay is 0 and 0. Sa focus naman is point rin siya, and yung location is at -3, and 0. So, ang directrix naman is line siya, hindi siya point, and yung line is paputol-putol along with the x-axis and nagkaroon ng vertical line. Kaya ang x is equal to +3. Ang axis of symmetrics ay line na humahati sa parabola sa two congruent part at ito yung gitna ng ating parabola. So, axis of symmetrics ay ang x-axis. So, ang axis of symmetrics natin is y is equal to 0. Ang standard parabola naman is nag-open sideways wherein yung vertex is 0 and 0 will be given by K and H. And yung K and H is our vertex na ang 0 and 0 ang value. So yung standard equation is x minus 0 is equal to 4 times -3 y minus 0. Again, yung 0 is sa vertex, yung -3 naman is nakuha sa focus, kaya negative siya, kasi nag-open siya sa left, kaya ang p-value will be negative. Now, to simplify the equation, ang standard equation parabola is x squared equals to -12y. Ellipse. Standard equation of an ellipse. May dalawang standard equation ng ellipse which is vertical and yung horizontal. Sa first graph, ang focus ay isa sa mga foci na meron ang isang ellipse. Now, sa center, ang variable will be hk at ang major axis na tinatawag is yung pinakamahaba or mas mahabang parte ng axis kapag nag-draw ng ellipse. And yung magiging formula ng ellipse kapag pa vertical will be x minus h squared over a squared plus y minus k squared over b squared is equal to 1, where yung h and k are the center ellipse and yung a and b will be the vertices. Now, dito naman sa pahiga or horizontal, ang kaibahan is yung major axis is nasa x-axis na, pero parehas silang may vertex and foci, same din yung center, still hk, but yung major axis is along with the x-axis na, kasi mas mahaba yung horizontal line kaysa sa vertical line. So, ang magiging equation is same lang rin dun sa nauna which is yung vertical, pero ang mas malaki na is yung A. Kasi yung x which is with A has a long part at yung major axis is yung x-axis. Kaya yung malaking number will be A. Para mas maintindihan pa natin yung ellipse, let's have an example. So, dito sa example, i-analyze lang natin ang isang ellipse by given graph. Kailangan lang natin i-analyze yung mga parts ng ellipse and maisulat yung standard equation. Sa graph, may makikita tayong vertices sa vertical axis which is 6 and -6, and yung co-vertices will be the x-axis is at 4 and -4. Yung standard equation natin is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So, ang h and k ang center na hahanapin natin sa graph at hahanapin natin yung a and b. So, unahin natin yung center. Ang center niya are in origin which is 0 and 0. At yung vertices, we have vertices along with y-axis and x-axis. So, sa x-axis, we have 4 and 0 and -4 and 0. Sa y-axis naman, we have 0 and 6 and 0 and -6. So, sa standard equation naman, kailangan muna ma-analyze kung nasaan ang major axis. So, yung major axis is nasa y-axis because mas mahaba yung distance ng vertex from center along with the y-axis. So, that means kung ang major axis contains the higher vertices value, therefore yung malaking number will be on the y-axis. So, ang equation natin will be x minus 0 squared over 4 squared plus y minus 0 squared over 6 squared is equal to 1. Yung dalawang 0 is the center which is yung HK and yung denominator, since yung x is mas maikli along sa x-axis, yung vertex will be 4 squared and yung major axis is nasa y. So yung malaking number will be with y. So, pag sinimplify natin ang equation, the answer will be x squared over 16 plus y squared over 36 is equal to 1. Hyperbola. Set of all points x, y in a plane. The difference whose distance from two distinct points, foci, is a positive constant. Ang vertex niya is yung red dot, then yung foci is nasa loob ng opening ng hyperbola. Value ng A is the distance from the center to the vertex, and yung value ng C will be the distance from the center to one of your foci. In hyperbola, we have a equation which is x minus h squared over a squared minus y minus k squared over b squared is equal to 1. This formula is same lang sa ellipse, but yung pinagkaiba is miniminus yung x-coordinate and the y-coordinate, and yung sa ellipse naman is ina-add.
In mathematics, a fractal is an abstract object used to describe and simulate naturally occurring objects. A fractal is a geometric shape or figure that is repeated within itself in a smaller scale. Fractals are called self-similar. That means each part is a kind of a mini mirror of the whole thing. Whether you zoom out to see the whole or zoom in to see just a part, you see the same shape. Fractals can be following a detailed pattern that repeats, or it may have a random pattern. Fractals are different from other geometric figures because of the way in which they scale. An example of fractals in plants is broccoli. Broccoli is an edible green plant in the cabbage family whose large flowering head is eaten as a vegetable. The word broccoli comes from the Italian plural of broccolo, which means the flowering areas of a cabbage, and is diminutive form of brocco, meaning small snail or sprout. So we have here a picture of a broccoli. Now, if you look closer at any of those little trees, you'll see even smaller ones that also resemble the entire broccoli. It's like a pattern that keeps repeating itself no matter how much you zoom in. That repeating pattern is what we call a fractal. Peacock is well known for its bright feathers, which often shows off in a magnificent curtain display, which is a good example of fractal in animals. If you look at the peacock feather, you'll find that the smaller sections, such as the eye spot, reflect the overall design of the entire feather, which is a fractal pattern. The technical term for these feathers is ocellated feathers. The ocelli consists of a central dark spot, known as the pupil, surrounded by concentric rings of vibrant colors such as blues, green, and browns. Lastly, an example of fractals in nature are mountain. When you look at the mountain ranges, you see the whole shape of it. But if you focus on just one mountain, it has similar shape to the whole bunch. It is like nature using the same pattern, whether you're looking at the whole shape or just one mountain up close.
Sierpinski fractals is a fractal based on a triangle with 4 equal triangles inscribed in it. The central triangle is removed and each of the other 3 is treated as the original was, and so on, creating an infinite regression in a finite space. In this figure, first, it shows that it was a equilateral triangle, and next, when we move a middle triangle on equilateral triangle, and treated the other 3 triangles as the original, and the process was so on that creating a infinite regression in a finite space.